the method of elimination. So we've learned solving systems graphically. We've learned solving systems by substitution. And then last lesson hinted at our third method of elimination. So let's revisit. Solutions to a system remain solutions if properties of equality are used to rewrite either of the equations, and the equations are added or subtracted, or any rewrite is added or subtracted. So it says, consider the system below. Solve the system two ways by eliminating x in the first, and then eliminating y in part B. Okay, so let's go ahead and start with that. So if I'm to eliminate x, let's see if my little pad's going to work here today that I write on. All right, so if we've got to eliminate x, we've got to multiply, we've got to get opposites over each other in order to eliminate. So I put parentheses around the second equation, and I automatically picked a 2 to multiply. So let's sort of think ahead here. If I need to eliminate x, I need to get, I've got 4x here, so I need to get its opposite below it, which would be a negative 4x. So in order to achieve that negative 4x, I've got to use that property of equality of multiplication, which makes the equation look different but doesn't change the value of it. So I go ahead and I distribute, so I end up with negative 4x minus 2y equals, plus 2y equals 16. And now when I add those two equations together, I eliminate my x's, and I end up with an equation, very simple equation, that I can solve for y. So now I've got y, I've got to find the x that goes with it, because remember, we have an x and a y that we're solving for in this. So I'm going to take that value that I just found, and I'm going to choose to put it into the first equation. You can put it into the second, it doesn't matter. And now, again, I've got an equation with one variable that I can solve pretty easily for. So I end up with negative 8, and x is negative 2. So my solution, okay, is negative 2, 4. So now, sometimes students will ask, they're like, well, is this right? And I say, you know how to verify a solution or how to check that solution. Take it, plug it into both. Remember, it's got to check into both equations in order for it to be a solution. So now the second equation says, or this system, it's the same system, okay, as it is in part A, but now they're asking us to eliminate y. So in order to eliminate the y's, I've got a positive 5y over a positive 1y. So I've got to force those opposites to happen. So 4x plus 5y equals 12. And I'm going to distribute through that negative, sorry, you guys can probably hear my dogs in the background again. Distribute through that negative 5. Now, when I add those two equations together, I get 14x. The y's go to 0, and I end up with, what does that give me? Negative 28. And again, I've got an equation with just an x in it that I can solve pretty easily. Negative 2. Okay, that should look familiar. Now, if I've got the x, I've got to find the y that goes with it. So 4 times negative 2 plus 5y. I chose to put it again into the first equation. It doesn't matter. And I've got a two-step equation that I can solve. So 5y equals 20, and y ends up being 4. So again, my solution is negative 2, 4. So you can see from those two examples that it doesn't matter what you choose to eliminate, whether you choose to eliminate the x's or choose to eliminate the y's. As long as you stay with these two steps up here, you're still going to come out with the same solution. Okay. Now it says show that the point that you found in A and B is the solution to the system. I'm not going to waste time on that right now. You guys know to substitute, okay, the negative 2, 4 into both equations. Sorry, like I said, you can hear my dogs. They're playing. And the 7-pound dog runs the house. She bosses around the 75-pound lab like it's her job. So, anywho, so solve the following system of equations by elimination and check. So again, doesn't matter whether you decide to get the x's or the y's to eliminate first. I'm going to choose, so I'm going to force the y's to eliminate. So I'm going to multiply this one by 7 and this one by a positive 2. So what does that do for us? So 35x minus 14y equals 70, and 4x plus 14y equals, that's 86. So now when you add those, I get 39x, the y's eliminate, and I'm left with 156. Divide by 39, and I end up with, I did this a different way in my notes, I believe that's 4. I'm just going to check this over here to see this division. Let's see, 6, 156. All right, good. I did that because, like I said, I did it a different way in my notes. So that's the x. So again, take that, plug it back into one of the originals, doesn't matter, and find the y. So negative 2y equals negative 10, and y is 5. So your solution is 4, 5. Okay. So let's deal with some applications here. Okay. Still kind of that exercise for your brain. It says, consider the line that passes through these 2 points. So if I plotted those 2 points on a graph and I connected them, we want to find the equation of that line in y equals mx plus b form. So this is kind of a cool way to write this equation. Actually, I've never seen it done before, but I was pretty impressed because it was different. I would have never thought to write this as a system to write this equation. It says, substitute both of the known points into y equals mx plus b to create a system of 2 equations with the parameter of m and b. So meaning we're going to solve for m and b. So there's my x, there's my y, there's another x, there's another y. So I would start off and I would say negative 11 equals m, my x is negative 2, plus b. And then the other one would be 14 equals m times its x plus b. So right now I've got a system of equations. So now it says solve this system for m and b, and then write the equation of the line. So I'm going to just sort of clean this up a little bit. So I'm going to put negative 2m plus b, and then I'm going to say 14 equals 3m plus b. So now I've got a system here. So again, force something to eliminate. I'm going to get rid of the b's because that's probably the easiest. Okay. So again, forcing that the b's to eliminate, I'm going to multiply through by a negative 1. So I end up with 11 equals negative 2m minus b. And then 14 equals 3m plus b. So I get 25 equals m. Okay, I think I made a mistake. Can't imagine why. It's not like I've had too many distractions here. Oops, that's a positive. Oh, for the love of Pete. Oh, gracious. Let's see if I can find my mistake here. So we have that. That gives us a 5m. Is m equal to 5? Yes. There we go. M equals 5. All right, so we found m, but we've got to find the b. And it goes with it. So again, take that, plug it back into one of the originals. I don't know, I might put it into the second one. 3 times 5 plus b. We get 14 equals 15 plus b, and b is equal to -1. So look at that. We have the slope and the y-intercept. So the m is the slope, the b is the y-intercept, and they asked us, solve this system for m and b, and then write the equation of this line. So y equals 5m minus 1. Whoops, 5x minus 1. Okay? So a different alternative for writing the equations of lines, obviously finding the slope and the y-intercept the way that we're used to doing it is a little bit more efficient, but I certainly could see that this is kind of interesting, this one. Okay, so part number 4, I think we'll kind of hop over. It's doing the same thing, but now it's giving you a table. So you could pick any 2 points on this table. Doesn't matter what 2 points you pick, you just need 2 points. And again, it's the same thing as question 3. The answer is, I'll give that to you if you'd like to try that, 1/2 x plus 4. And now this one, it's the same idea, but it's just talking about 2 numbers. It says 2 numbers have the following properties. The sum of the larger and twice the smaller is equal to 13. So I probably would start off with a let statement. So I'm going to say let the larger equal x and the smaller equal y. And then it says the sum of the larger and twice the smaller is equal to 13. Now the second sentence here, the third sentence says twice their positive difference. So the positive difference means the larger minus the smaller. That would be the positive difference between 2 numbers, the larger number minus the smaller. If we did the smaller minus the larger, that'd be the negative difference. So twice the positive difference, so larger minus the smaller, difference means subtract, is equal to 8. And what are the 2 numbers? So that first equation I would leave as is, but I've got to distribute for the second equation to clear those parentheses. And now when I look at it, I don't even need to force elimination to happen because it's already there. So I end up with 3x equals 21, x equals 7. So the larger is 7, but now I'm going to take and plug that into the first equation. So 7 plus 2y equals 13. 2y equals 6. And y is 3. So the smaller is 3. All right, go ahead and flip over. We're going to kind of hop around a little bit in this lesson so as not to make this video too long. Let's take a look. Let me see if I want to do, let's go to, let's do number 2, exercise 2. Okay, so go ahead and flip the page again. So we're still doing elimination here, but now we've got a little bit of meaning behind this. So it says Samantha went to a concession stand and bought 3 pretzels. So, whoops, let's get some information here. 3 pretzels and 4 sodas and paid a total of $11.25. And then Raza went to this, or Raza, I'm not sure how to say her name, went to the same stand and bought 5 pretzels and 2 sodas and paid a total of $8.25. So it says, could pretzels have cost $1.75 each and sodas $1.50 each? How can you evaluate based on this information? So what they're saying is $1.75 and $1.50 a solution to this system? So in other words, they're asking us to check this idea. Is it feasible? So 3 pretzels, so 3 times the cost of a pretzel, supposedly, is $1.75, plus 4 sodas, $1.50, for a total of $11.25. And then for Raza, let's see, is that true? If you go through and evaluate that, we end up with that this is true. That first one is true. And now let's try to do the same thing with the second person. 5 times the number of pretzels plus 2 sodas. Does that equal 825? Doing that calculation, that comes out to be false. So is this, could these cost this? No. Okay, they cannot. All right, it's an and, like I said, it's an and situation. It's got to be true for both. So it says letting X equal the unit price of a pretzel and Y the unit price of a soda. Write a system of equations that models this information. So Samantha would be 3x plus 4y equals 1125. And then Reza would be 5x plus 2y equals 825. Okay, so now it's saying solve this system by using elimination. So let's just rewrite that. And if we're using elimination, as I glance at both of those equations, I see 3 over a 5 and I see 4 over a 2. Well, I can use that property of equality that I would probably want to get the y's to eliminate. If I could multiply through by -2. Okay. So that first equation is going to stay the same. I'm not going to do anything to that. I'm going to keep that as is. But distribute through that -2, and we end up with -1650. So now the y's end up eliminating, and we end up with -525 dividing by 7. We end up with the pretzels are, as X is pretzels are 75 cents. So take that value and substitute that back into one of the equations to find out the cost of a soda. 25. So $2.25 plus 4y equals 11.25. 4y equals 9. Dividing, we end up with 2.25 for a soda. I should label these, make sure you label them. And that's the cost of a pretzel. Okay. If Leah went, excuse me, to the same concession stand and bought 2 sodas, how many pretzels would she need to buy so she spent the same amount on both? I'm going to pause on that one. Okay, I'm running out of space, so I needed to create a little here. So if Leah went to the same concession stand and bought 2 sodas, so 2 sodas, 2 times 2.25, how many pretzels would she need to buy so that she spent the same amount on both? The same amount means equal. So pretzels are 75 cents each. We'll call that N. Okay, N is the number of pretzels. And we end up with 450 equals 0.75 N. Divide by 75 cents, and we end up with 6 pretzels, so that she spent the same amount on sodas and pretzels. Okay, and then the last one, a little bit of geometry here. So it says, I'm just going to set this one up, and then I'll give you the answer. So it says a rectangle has a perimeter of 204. Oops. Rectangle, holy smokes. What's going on here? Okay. Perimeter of 204. So if you remember, perimeter formula is 2W, okay, 2 times the width plus 2 times the length. that's going to equal the perimeter, 204. So now, okay, it says if its length is 6 feet longer, 6 plus 6 feet longer than twice the width, 2W, okay? And then it says, I assumed, if L stands for the length and of the rectangle and W stands for the width, write a system, okay, that models this information. So we just took and modeled that information. Now, in order to solve this, we certainly could do this by substitution. I would say go with substitution here instead of elimination, just because the way this is set up. If you notice, L is by itself. So you could absolutely take that, that's your representation of L, 6 plus 2W, and put it right there. I absolutely would go with substitution here and not elimination. So we could say 2W plus 2. Here's my substitution. Okay, I'll put it in blue. 6 plus 2W equals that 204. Okay, so that's going to give you, I'm just going to find that answer real quick. So you can stop here. So your W is going to come out to be 32. And then when you substitute back in, your length is going to come out to be 70.